In this tutorial, I'm going to show the quick method to find the gradient of the tangent of that expression. So we need to differentiate on the both sides. It's an implicit function. If we differentiate with respect to x, we would get from here, from the first expression, x cube gives us 3x square. Then this is 3y square, then dy by dx. And from the 9xy, we need to apply the product rule, dx dy by dx plus y into d by dx of 9x gives us 9, and then if we differentiate 9, it gives us 0. So that is the way we can differentiate it. Rather than making dy by dx as a subject, best way to put the value of x and y in this equation. So if we put the value of x instead of x, which is 1 square, plus then 3y is 2 square dy by dx, and on the right side 9 into x value is 1, and you can write here in beside it dy by dx, plus last one is y into 9, y is 2 into 9. So from here we got 3 plus 3 4 is the 12 dy by dx equals to 9 dy by dx, 9 dy by dx plus 9 to the 18. So now easily can write 12 dy by dx minus 9 dy by dx equals to 18 minus 3, which is 15. So from here we can take dy by dx common, then 12 minus 9, which gives us, we know 3 equals to 15. So dy by dx equals to 15 by 3. We can cut out, and we got from here 5. So this is our answer of that expression. This is where rather than doing dy by dx making subject, we can put our value just after the differentiation. Let me see another question. Say this is another question. Find the gradient of the same procedure we are going to apply here, which gives us gradient of the tangent, means we need to differentiate with respect to x in this implicit function 6x plus this gives us 4y, then dy by dx equals to 2x dy by dx, then plus y into, if we differentiate 2x, it gives us 2. We are going to apply here on this 2xy as a product rule. We know 2x is one part and y is another part, d by dx. Then we know the product rule, dy by dx plus y into d by dx of 2x. So from there we got this one, because it's a y as a function of x, so y into 2. This is on the right side. And if we differentiate the 23, we got from here 0. And 2y square, if it is written there, say 2y square, it is actually d by dy of 2y square, then you can write it dy by dx, same as d by dx of that one. So from the first part we got from here 4y, then dy by dx, because we cannot do anything, we need to keep it dy by dx because y is a function of x. So we did differentiate 2y square like this, which comes from here. Hope you understood. Now rather than making dy by dx subject, let you put the value, x value 3 and y value is a 2 in that expression. So if we put x value 3, then it becomes 6 into 3 plus 4 into 2 dy by dx equals to 2 into 3 dy by dx. Then next is y, which is 2 into 2. So 4 to the 8 dy by dx, 6 dy by dx. If we subtract from there, we can write here 8 minus 6, which is 2 dy by dx, 2 dy by dx. And on the right side, 2 to the 4 and 3 6 the 18. So 4 minus 18, which is minus 14. So now if we make dy by dx, then you can write it minus 14 by 2, and it gives us minus 7. So this is the value of this question. It is written here, gradient of the tangent. This is the gradient of the tangent of this expression at that particular point 3 and 2. Let we go for another question rather than making dy by dx subject. How we can do it quickly? We need to apply first part as a product rule, second part as a product rule, third part as a product rule. Okay, let me apply the product rule and doing the differentiation quickly. X cube is the one part here, then dy by dx plus y into, if we differentiate x cube, it gives us the x square. This is the differentiation of the first part, this part, then plus that part we are going to differentiate 2x square y square, so which is 2x square into 2y, then dy by dx plus y square into 4x. So actually we split it 2x square in one part and y square is another part. We need to apply a product rule. If we apply the product rule, then we got from here like this. And on the right side, if we differentiate, which is written xy cube, so I can write it x into 3y square, then dy by dx plus another part is y cube into 1, because if we differentiate x, then we got the 1. So now it's time to put the value x as a 1 and y as a minus 2, rather than making dy by dx as a subject. So if we put x equals to 1, then 1 cube dy by dx. Now easily you can simplify it. Y equals to minus 2, then 3 into 1 square plus 2 into 1 square into 2 into y value is minus 2, then dy by dx plus y square, which is minus 2 square into 4 into 1, and on the right side it is 1 into 3 into y is minus 2 whole square, then dy by dx plus minus 2 to the power 3 into 1. Okay, let me simplify. 1 cube is 1, so you can write it dy by dx directly. Then the next part is we need to calculate, which is 3 into 1 square 3, 3 into minus 2, which is minus 6. 3 is the minus 6. Okay, next one, this is the next part. Next term, it gives us all are with the multiplication. 2 to the 4, 4 to the 8, so it is minus 8 dy by dx, we can write here. Okay, next is this one, 4 into 4, which is 16, yeah, plus 16 we can write. And on the right side it is 4 into 3, which is 3 4 is the 12, 12 dy by dx, 12 dy by dx, in negative 8. So that is the total expression. See how quickly we did this question. Rather than making dy by dx as a subject, just do the differentiation and put the x and y value. Automatically it becomes very smaller. Now let you consider all dy by dx is in one side, which is dy by dx, then minus 8 dy by dx, 8 dy by dx, minus 12 dy by dx, all dy by dx in one side, and minus 8, then minus 16, then another one which is goes plus 6 together. So now we're going to calculate here, which gives us, if we take dy by dx common, then the part is 1 minus 8 minus 12, and from the right side we got minus 18, and from the left side we got, I think, minus 19 dy by dx into, which is minus 20 plus 1 minus 19, minus 19 minus 18. So therefore you can write dy by dx equals to negative 18 divided by negative 19. We can cut out this 2 minus sign. 18 by 19 is the result of this expression. So 18 by 19 is the gradient of the tangent of that expression. This is the quick method of implicit function. So you are welcome to see my